In this problem, I need to verify this trigonometric identity. And looking at this identity, I think I need to start on the right-hand side since that looks like it's the more complex of the two sides. So I'm going to write the right-hand side out. And it's cosine x times tangent x plus sine x, all divided by tangent x. And now before I do anything else, I look at what I'm trying to prove. All I'm trying to prove is this equals 2 cosine x. So I have a cosine x here, but I've got tangents and sines in here too. So I think what I'm going to do on this problem is write everything in terms of sines and cosines and then see what happens. So remember, we know that the tangent of x is equal to sine x over cosine x. So that's the first thing I'm going to do, is turn both of these tangents into sine x over cosine x. So since I have a cosine x times tangent of x, which is a fraction, I'm going to write my cosine of x as a fraction too. So cosine of x over 1 times the tangent of x is sine x over cosine x plus sine x, all divided by sine x over cosine x. Right now it looks pretty messy, but let's see what happens. And if you notice in this term here, something nice happens. This cosine x reduces with this cosine x. So I'm just going to get left with here sine x over 1, which is just sine x. So I have sine x plus sine x over my sine x divided by cosine x. So looking at my numerator, I have sine x plus sine x, which is 2 sine x over sine x divided by cosine x. Since I have a fraction in my denominator, I'm going to make my numerator a fraction just by taking 2 sine x and dividing it by 1, all divided by my sine x divided by cosine x. And now how do we divide fractions? You take the fraction in the numerator, leave it alone, and multiply the reciprocal of the denominator. How do we find the reciprocal of a fraction? You just flip it upside down. So I'm going to have 2 sine x divided by 1 multiplied by the reciprocal of my denominator, which is cosine x over sine x. All I did was flip this fraction upside down. And now if you notice, this sine x reduces with this sine x since those two fractions are multiplied by each other. And what do I get left with? 2 times cosine x is 2 cosine x, all divided by 1 times 1, which is 1. So that's going to give me 2 cosine x. And was that what we were trying to prove? Yes. So that equals the left-hand side. So I have proved that the right-hand side equals the left-hand side.